All right, welcome to The Explainer. Today, we're tackling a really high-stakes challenge that every enterprise leader is facing, the multi-cloud AI dilemma. How do you build a truly world-class AI capability without, accidentally building yourself into a prison of your own design?
And really, it's a question you have to ask yourself. You're pouring millions into talent, data, and models, and you're using the incredible power of the cloud. But what if that power comes with invisible bars? What if the very platform that's helping you move so fast today becomes the cage that completely limits your strategy tomorrow? This isn't some abstract theoretical risk. This number right here, $8.5 million. That's the real cost one healthcare company had to pay just to get out of its cloud contract after some unexpected price hikes. Think about that. $8.5 million, not for innovation, not for a new project, but just for freedom. That is the very real threat of vendor lock-in.
So what exactly is vendor lock-in? Well, it's way more than just an inconvenience. It's a strategic paralysis. It's caused by things like proprietary APIs that just don't work anywhere else, massive costs to move your data, and having to retrain your entire staff. It's that tipping point where you're not choosing your provider anymore. Your provider is basically dictating all of your options for you.
Now, you might be thinking, okay, the industry's answer to this is multi-cloud, right? And you'd be right. This chart shows that nearly 90% of companies have adopted it to spread the risk around. But, and this is the absolute key to this whole explainer, for AI, just using multiple clouds is not enough. The complexity of AI workloads creates these new, much more subtle traps that can lock you in at a much, much deeper level. So here's our game plan for this explainer. We're going to lay out a blueprint for genuine AI independence. We'll start by unpacking the vendor lock-in paradox. Then, we'll introduce the core concept, a dual-layer solution. We'll do a deep dive into each of those layers, the foundation and the accelerators. And finally, we'll pull it all together to show you how to architect your own freedom. All right, let's dive right in with the paradox itself. The very clouds that promise you infinite scale and flexibility, well, they can actually impose some severe economic and operational limits, often in ways you just don't see coming until it's way too late. Okay, you really need to look at this chart because it shows where the real financial pain is. We spend so much time talking about compute and storage costs, but the silent killer for multi-cloud AI is data egress fees. That's the cost to move your data out of a cloud. For AI applications that use tons of data, these fees can be absolutely astronomical. They effectively hold your training data hostage, making it financially impossible to train your models on whatever platform might actually be the best for the job. And it's not just about the money, right? There's a huge operational risk too. We've all seen the headlines. Even the biggest cloud providers have outages that can bring a business to a dead stop. And this quote just nails it. When you rely on a single provider, you've just outsourced your single point of failure. If you want real business continuity, real resilience, you need the flexibility in your architecture to shift workloads and data across different clouds whenever you need to. Okay, so if vendor lock-in is the big, scary problem, what's the solution? Well, it's not about ditching the powerful tools the cloud providers give you. It's about being smarter in how you architect the way you use them. And that brings us to the core idea of this whole explainer, the dual-layer solution. The best way to think about it is like you're building a brand new high-tech corporate headquarters. You wouldn't build your super specialized billion-dollar labs directly on shifting sand, would you? Of course not. First, you lay down a standardized universal foundation and frame that can be built anywhere. That's your layer one. Then, inside that strong, portable structure, you install all the custom, high-performance equipment and labs. That's layer two. So let's break this down. Layer one, the infrastructure layer, is your universal foundation. It's all about using open standards to manage the basics, compute, storage, networking, in a way that's exactly the same no matter which cloud you're on. This layer gives you portability. Layer 2 is where the AI magic happens. These are the powerful AI stacks like SageMaker or Vertex AI. They are your specialized power tools that speed everything up. So one layer gives you freedom, the other gives you power. The trick is making them work together without one canceling out the other. Okay, so let's get into the nitty-gritty of layer 1. How do we actually build this universal foundation for our AI headquarters? Well, the answer lies in setting up a multi-cloud control plane. And the absolute cornerstone of that is Kubernetes. So the star of the show here is Kubernetes, or K8s, as you'll often hear. It's really become the standard for this stuff.
It's basically a universal translation layer. It packages your applications into these things called containers and then manages them consistently, whether they're running on Google Cloud, AWS, Azure, or even in your own data center. It lets you write your app once and then run it anywhere, which is pretty much the definition of portability.
Now, to manage Kubernetes across this whole complicated landscape, you need a control plane. And the two dominant players in this space are Google Anthos and Microsoft Azure Arc. And what you'll find is that they have two totally different philosophies. You can think of them as two different master architects. Google Anthos is the architect that's all about giving developers maximum flexibility and speed. Microsoft's Azure Arc, on the other hand, is the architect that's obsessed with centralized governance and control.
And you can really see those different philosophies play out in this table. Anthos is built on pure Kubernetes, so it feels really native to multi-cloud development. It's focused on creating one unified development experience. And it uses a GitOps model for governance, which basically means managing your infrastructure with code, the same way developers manage software. Azure Arc, though, uses the Azure Resource Manager, or ARM, as its core. Its whole goal is to stretch Azure's powerful management and security policies over any resource anywhere. So the choice really comes down to your priorities. Do you want developer speed with Anthos or centralized security with Arc? And of course, you've always got the open source option Kubeflow, which gives you that portability without the licensing fees.
All right, we've poured the foundation. Now it's time to build out layer 2, the accelerators. This is like outfitting our headquarters with all the cool stuff, the specialized labs and workshops, those powerful integrated toolkits that are going to actually produce our AI breakthroughs.
And this is where you hit the really tough question for layer 2. These amazing high-end toolkits, these MLOps platforms, they often get their incredible performance by using proprietary tech, including their own custom-built hardware. So you're faced with a major trade-off. Do you go for the absolute best performance, which might tie you to a single vendor's ecosystem, or do you prioritize long-term strategic portability, even if it means a slight hit to performance? So let's take a look at the big players on the field here. AWS SageMaker has a huge ecosystem of tools. Google's Vertex AI is a fully managed platform with a major differentiator. It's deeply integrated with its custom TPUs, or tensor processing units. Then you have Databricks Mosaic AI, which is all about a data-centric approach built on its lakehouse architecture. It's got a heavy focus on Gen AI stuff, like RAG, that's retrieval, augmented generation, and vector search, which are super important for building modern AI chatbots and search tools. Each one is incredibly powerful, but their biggest strengths are also what can lock you in. And this, right here, this is the perfect example of that new, sneakier kind of lock-in. Even if you have a portable Kubernetes foundation, if your most important AI model is optimized to run on Google's custom TPU silicon, you've just created a powerful dependency at the application layer. So you have freedom at the infrastructure level, but your most valuable workload is now a captive of one provider's special hardware. That's the performance versus portability trade-off in a nutshell.
Okay, so we've got our two layers, a portable foundation and those high-performance accelerators. The last step is to bring it all together into a smart, coherent master blueprint, a strategy that balances that freedom and power, all governed by smart policies. So to actually make this dual-layer thing work in the real world, you've got to follow a few key rules. First, agnostic data storage. This is totally non-negotiable. You have to separate your data layer from your compute layer to get a handle on those killer egress fees. Second, federated governance. You need a single, central way to manage identity and security across all your clouds, using stuff like single sign-on to stay in control. And third, strategic workload routing. This is where you get really smart, using automation to send different AI jobs to whichever cloud is best, either the cheapest or the most powerful for that specific task. So, if you're going to take away 3 things from this explainer, let it be these. Number 1, prioritize governance first. Before you let your teams start spinning up servers everywhere, get your control plane established, lock in your security and compliance policies. Number 2, make sure your data is agnostic. Yeah, this means investing in things like neutral storage and private networks, but it's the investment that guarantees your freedom from egress fees down the road. And 3, segment your workloads. Don't use a sledgehammer for a thumbtack. Use flexible, open-source tools like Kubeflow for your everyday portable jobs. Save the expensive proprietary platforms for those truly mission-critical tasks that absolutely need that specialized hardware. And look, making these choices right now, it's never been more important. The future is all about massive, purpose-built infrastructure. We're seeing huge investments, like Microsoft's reported $110 billion plan for what they're calling AI factories. The competitive edge is increasingly coming from owning the whole stack, from the custom chips all the way up to the software. And as these walled gardens get taller and more powerful,
having your own independent foundation becomes an existential issue. And that really leaves us with one final crucial question for you. The architecture for your company's AI-driven future is being laid down right now, with every single decision you make. So you have to ask yourself, are you strategically and intentionally laying your own foundation on solid ground, or are you just building your most valuable asset on someone else's land and just hoping they'll always be a benevolent landlord? The choice is yours.